Hello, good morning. My name is Gerald, and I'd like to introduce my colleague Tom Pedersen. Tom Pedersen actually is a trainer within the Bosch training organization, responsible for training in the Nordic regions. That's everything north of the river Danube. No, just joking.
No.
It's the Nordic countries.
North of the wall, right?
Okay.
Yes, thank you, Gerald. Gerald is an AR product manager and has been doing AR for what, 5 years, more than 5 years now? Yeah.
6 years, yeah.
Yeah. What I want to talk about today is how we are using the AR in our technical training in Bosch. We are doing a lot of technical training for the automotive division, and to understand the challenges for the workshops, I think that we should start up with what is the workshop dealing with today. Today at the workshops, a lot of cars are coming in with a quite complex engine management system. We are talking about cars with hybrid systems, electrical cars and cars with range extenders. We are talking about a lot of cars with downsized engine. So we are talking about engines with direct fuel injection, turbo and compressor in one and the same engine. So we are giving the workshops a lot of challenge in this matter. Just imagine that in Norway, where I do some training, more than 50% of all new cars sold are hybrid or pure electrical. They will come into the workshop, and they do come into the workshop right now. We also have a lot of cars with ADAS, camera radar systems. This is a challenge for the workshops because the camera and the radar system needs to be dealt with. If they are doing a windscreen repair or alignment of the wheels, you need also to align the camera and radar systems on these cars. Some of the challenge here is that you need to align them in the precision of 0.2 of a degree. So this is a challenge for the workshops. We also have the ECUs, electronic control modules. So this is the computers that are guiding all the systems in the car. And nowadays it is quite normal to have 50, 60 or 70 ECUs in one car. They need to talk to each other by CAN bus, by MUST, by LIN bus, or short, low, how is it called? Come on. High speed or low speed CAN bus, sorry. So to figure out just where are one of these computers placed in the car physically, we have a mechanic that needs to measure on the computer, but where is it? This is a challenge for the workshops. So the workshops today are using computers or paper guiding on how to repair the cars. They are used to taking cars apart, but it is very time consuming if you need to rip all the interior apart to get to the stuff that you need to repair, right? So then of course we have a couple of trainings. This is our training center here in Plockingen, and we are right now doing some 1,800 training per year. So that is 14,000 participants, okay? So we are doing a little bit of training. And the challenge for me as a trainer is obvious. If I need to train a mechanic in these complex systems, I need to borrow a car, and then I need to rip it completely apart. That's a challenge. So also the participants, they are used to be actively working all day in the workshop. They are quite used to figuring out what is wrong with parts by taking parts apart, having them physically in their hands, and that's the way they are used to work. They're not used to sitting down looking at PowerPoints. If I present them a PowerPoint, then I will have their attention for what? 20 minutes? Then they will fall to sleep. So what I can do is, this is a small video from the first training I did with augmented reality. No. So this is, could I get some sound? Thank you. So this is the training we did in Copenhagen, the first one. And pay attention to the participants. The participants are joining in, they are asking questions, they are keeping on talking to each other about what they see and what they do. And just 3 weeks ago at Automechanica in Frankfurt, we did 1 or 2 training each and every day for a whole week, and we saw the same behavior. As soon as we shifted from the presentation and to the augmented reality, people were joining in the training. They were actively coming with questions and asking each other and me as a trainer what they were looking at. So we are having a complete another way of training. And in this way we can show very complex matters in a visual way for the mechanics. Okay? And how this is done, Gerald.
Thank you, Tom, for the introduction into training. As you may have seen, I mean, it was very vehicle specific, obviously, but it is a challenge to follow technology developments with the speed that it grows today. New technologies, new complexities, and a whole lot of variances to manage and to understand. That's why starting in training centers is the logical approach to roll a new technology first out in terms of applying augmented reality into training, and secondly also to apply it for new technologies. And that's why I see, why do we do this? Because we want to help technicians do their job faster, better, and without any mistakes. Why electric vehicles and hybrid technology? I mean, it's a new technology. It's a sensitive technology, and it needs understanding. And what Tom just said, in the past, when we had to dismantle a vehicle or dismantle an engine, it was quite simple because it was mechanical parts. But today, it's electrical parts. It's not that easy anymore. So augmented reality is the logical step to present and provide the insides of a component, of a part, of an engine, of a vehicle, and let the training participants understand it. Also, new technologies require new methods. New methods require new special tools. As such, augmented reality in terms of a technician is another special tool, like a bended torque wrench 20 years back. And obviously, it allows new concepts in training. It offers a lot more interactivity with actually touching systems or working on systems that are not that easy to maintain. And that's why we developed and put together the Training 4.0 solution. It's based actually on the platform that Jürgen and Wolfgang just mentioned before, and I will give you some more details on that in a few minutes. So what do we do? A training center is usually providing training courses for a group of technicians, 10, 15, 20, maybe 25 participants, learning about a system, learning about components, learning about methods. That's why we developed a trainer mode that allows a trainer who did training before on a real object, physically dismantling something, controlling devices that the training participants also either hold in their hands or wear on their heads, like a tablet or HoloLens glasses, and see what a trainer explains to them. standing in front of a real object or even without a real object than in a virtual simulation or holographic demonstration of the product. So the trainer controls the actions, the trainer controls the interactivity of the 3D model, the participants see what the trainer is explaining to them and what the trainer wants them to learn, actually. A trainee mode then allows a trainee to do something, and the trainer gives over direct hints and tips on a specific question, for example. A schematic view of that is you have a trainer, the red M, moderating a training course in front of an object or in front of the scenario, let's say, and the training participants see the same. All the HoloLens devices or the tablet devices are connected in one session, connecting to the session that's hosted either on the trainer's device or on a server, depending on which network setup has been chosen, and view the same scenario around. This is the typical training setup we do here with 3 people, up to 10, 15, 20 people, so we can support the full training session just in the past. Important to say also, it's not only limited to a specific location, so the participants not necessarily need to be in the same room. It can also be done on a remote location. So a trainer that sits in one room can interact with training participants that sit in another room or even another location, even another region globally, depending on the network settings. So it's not just about training, it's about really combining information into sessions that are made available on a larger scale. If we now want to have a free exploration by the trainees so they can do and explore their own scenario, the trainer can still interact and moderate and give hints from outside. It's just he's not controlling their devices that much anymore. Maybe call it like a private session of training. So how do we do this then? And in the presentation before, you already heard about platform. It's important to enable trainers like Tom and his colleagues to create trainings or provide them with trainings every day with new components, with new topics, with new vehicles, with new variants of already existing documentation. And how do we do this? We have training authors creating that content. No programmers. It's authors that today write technical trainings are now able to also provide this into an augmented reality app, which is a client that runs on a HoloLens or on a tablet device. So authors use authoring tools in a content management system, publish the content to a runtime server, and the client on the HoloLens or the tablet consumes the content fetched from the runtime server. The session, to combine this all in a training scenario, is part of the client. Also, very important if you talk about a bigger rollout and a large rollout, not just on a HoloLens, also on tablet, on iOS, on Android, on Windows, so make the content available device and operating system independently. That's a process kind of view. If you look more technically, it's the same methods and principles applied that we know from technical documentation. So training modules that are created in XML, 3D objects that are created, authored, manipulated in a 3D editor, now combined together with AR technology like tracking, be it an object tracking or a market tracking, added on top of it, published it to the runtime server, and then make it available on the client. So for the training authors, it's not more difficult, not more complicated to create the content. For the consumer, it enables now to do the same training concept added on with augmented reality features. And this make it applicable for many more products, many more variances in different locations. What are the building blocks of such solution to roll it out? Obviously, talk about how that rollout will work in terms of a consultancy model. What are the requirements for solutions? We've heard in the presentation before, software developers don't become obsolete. It's still a requirement to enhance solutions, to add additional functions, to integrate into different other solutions, like a learning management system, for example. What actually does the customer need? Then a software package, including the authoring and the runtime systems, etc. The authoring services and the training, how to create the content, how to use the system, how to utilize the system, how to apply it best in a training environment. And then obviously the integration. These are the building blocks built together, very roughly only applicable for sales training, for technical training, for production training, because the process is the same. It's a different story that I'm telling, but they apply the same technology. And why we as Bosch? Because our training colleagues, our training centers, our training organization that provide basic trainings on technology and specific trainings on specific applications of technology are the ideal partner to scale up this solution, to test it, and augmented reality is the ideal platform to enhance their training capabilities. As you've seen, 15,000 training participants year by year that are potential augmented reality users. Why in training? Because training is the ideal platform to not just learn new technology in vehicles, but also new technologies and new processes and methodologies in applying repair processes into a workshop. So if you not just learn the high voltage component, but also learn how to repair them by using augmented reality applications and augmented reality headsets or tablets, it's a double use case of scaling this solution into the workshops at a later stage. At the end, what are the benefits? And that's something Tom already experienced. It's about enhancing training methods in the workshop environment for the more complex systems. It's getting the people back on attraction, let them interactively participate on augmented reality, since it's new by itself already does a lot. So it supplements, it enhances, it adds to the classical training methods that we have today. The more complex the systems is, the more advanced the technology should be to train that. It's interactive. Obviously, it's a non-destructive method of explaining the insights of products, of engines that are not easy to dismantle. It makes information available in places where a real vehicle or a real product is not available, and it puts the information at the right place in the right time. As this increases the quality of training, and also, talking back about the remote capability of the solution, reduces the cost by limiting traveling. Could even imagine that training participants sit at their home space and do training and participation there. On the other hand, it's a reduced effort to create the training modules by using 3D data and augmented reality instead of building, cutting real objects. They are usually quite expensive and not necessarily available at any place, and platform independent across all the systems.
So what we have done is that we have decided to make our training centers augmented reality equipped. This is already being started in Denmark, and we will do it in five countries this year, we believe, and then we will spread it out in all the rest of our training centers, because we believe that this is the way to do a modern and efficient training with all the new technologies. The first training we have done until now, I started in the start of 2018 with the first hybrid electrical training with augmented reality. Then I've been doing it the whole year to get best practice, to see what works and what doesn't. And then we came to Automechanica, where we did 1 or 2 trainings each and every day for a whole week. And that gave us a lot of testing of the system. And now we are going all in for augmented reality in our training centers. Yes.
Yeah, and content for new courses is already in the process of being developed, so it will roll out one by one, more and more technology topics, more and more locations, more and more regions, but all now supported by augmented reality.
Yes. Super.
Thank you, Tom.
Thank you, Gerald. Thank you.
Thank you very much. I think we are now open for questions.
If there is any question, that's not sure.
Yes, we do have questions.
You have questions.
Guess what?
You're just late.
Starting with the first one. In which case you use an HMD and when a handheld device is more applicable? What are the pros and cons of these two options in every industrial application?
Yeah, if I may answer this, I think it depends on the availability of the device. In a training center where the equipment usually is available, we would use head-mounted devices at this time. In not a training, but a real use case like repair on machines, on production machines, for example, we already might use head-mounted displays because in relation to the overall cost of such a big machine, it's a relatively small investment. If you talk about workshop use cases, more likely that tablets are available, so we would use tablets there. So it really depends on the availability of the device. As I mentioned before, the AR client is available to consume the same content on either device or the other.
As a trainer, a tablet is certainly one of the best things to have because it's more easy to guide through using the tablets, but all my participants need to have the HoloLenses on to do the training. Yeah.
Okay. Going for the next one, how do you measure quality and success of the RI training? I assume less accidents and more efficiency?
That is a good question.
Yeah, we can immediately see the quality because all our training will end up with a test where we go through all the steps that we have done in the training, and you can see by the rate after that we are way above what we normally do. So all the time when they are normally looking at their smartphones or thinking of what's going on at home, then I have their attentions when they are in augmented reality training. Yeah.
So at the end of a training course, there's usually a test participants need to answer and get a certificate. And if they pass the overall training, AR is one part of it. Important factor is when new vehicles go to market, it usually takes 6 months until they first appear in a workshop. So the knowledge retention between the time that something was trained and the actual application in a workshop is quite long. And studies have proven that augmented reality helps a lot and provides a lot of very high factor of knowledge retention. So if I have done it using visual guidance, I remember much easier 6 months in the future what I have learned now.
Okay. As the next one, how many AR headsets does Bosch have in their training operation? Now I'm trying to pronounce even Bosch like an American way, Bosch.
What did we have
do we know how many we have? I'm not really sure. We do have at least 2 training centers fully equipped for a training course. That's 15, 20 pieces each. More hopefully to come. Headsets and then tablets on the other hand are quite more.
Okay. As for the next highlighted one, what is the cost structure to create a training session? How much % in HoloLens content creation percentage? More or less.
That's not that easy to answer. I mean, the HoloLens setup is the prices we pay just.
But I assume you get like a pretty neat discount from Microsoft. But when it comes to the content creation, is there even a way of calculating how much that will cost in order just to introduce that within the training session?
Yeah, but we bought them officially. But as said, we have a training, an AR client on the HoloLens on the tablet devices that can consume any AR content that's been created using our CAP augmented reality platform. So we buy a device once and we use it for unlimited number of use cases depending on how much content has been created. If we talk about a training course, maybe 15, 20, 25% of all training class, duration 1 day, is done using augmented reality, having augmented reality with it. The creation itself is authoring exercise, XML, 3D editing, and then publishing to the device.
All right. Another one highlighted. Do engineers have to turn into IT specialists and 3D artists to author AR training? I mean, that's going to probably, you can tell us something about your background again?
Service technician today is an IT specialist, yeah. When you are working on a modern car, I believe that some 50% of the work time you are dealing with the computer and not with the car. So yes, you are already an IT specialist. You need to upload and download software every time the car is at the workshop. So yes, they're already there. But what I see here with AR is that we can take a lot of that job down and visualize it for the auto mechanic. So it is clear what he has to do and how he is going to do it, instead of him looking through hundreds of pages in a guide how to repair the car. We can show it here by augmented reality.
But I also understand in the future it will actually get better as the technology is going to be more available, or?
But I think the question here is more, do we need to program AR? No, we don't. So they are not IT specialists in terms of programming an AR app. It's really authors creating XML content, 3D content, all tools and processes and media types, let's call it, they are used to do today. Today they are creating graphics or animations from 3D data, describing everything in XML. The same principle methodologies are now used to create content and publish it to the AR client. No programming need to create or program or compile an augmented reality app.
All right, for the next one. How do you ensure data security of valuable information in a global rollout?
Usually, in the cases we are talking today and nowadays is we are linking the technology with the available infrastructure of workshop information system, training center infrastructure. So it's not publicly available in the internet and freely accessible. It has a full, let's say, level of control within internet infrastructure. Data security in terms of 3D data, CAD data, we are not using CAD data, we are using 3D representations of engineering data that would not allow anybody to use this information for a purpose other than visualizing it in training or repair use cases.
Okay. Do we still have time for another one? Yes. What have you found to be the optimal amount of time in the HMD for active training experiences?
Depends. The evaluation on this is still ongoing. We have colleagues that after 2 minutes need to get off the head-mounted display and change back to tablet. We experienced that 15 to 20 minutes by really concentrating on it is not a big issue for a reasonable big number of users, and not for everyone.
At Automechanica, we did in fact do a stress test. So the participant there has never had HoloLens on, and they were forced to have them on for 1 hour, and that was not a problem. It wasn't a problem, but I would never do that in my training because we need to shift forth and back in what we are talking about. But it is possible to have them on for 1 hour without complaining, even though it was the first time ever.
My personal record was 30 minutes, but that's not average.
And then we have to see like what came out of it. Well then, guys, thank you so much for your time. Again, like when it comes to some further questions, you can visit the booth. Well, thank you so much, guys, for being here on stage. Thank you.